Good morning and welcome back. Today we're going to start our second conic section called Parabolas, something you saw all of last year. We don't teach much new except one new term called the lattice rectum. Yes, it is in our notes. Look at the back page of today's notes. You'll see what the lattice rectum is if you want to jump ahead and see now. It's just as funny as asymptote. Anyhow, it's nice and early in the morning for me. For you, it's probably about 3 in the afternoon. So we're going to start with parabolas. I'm not really going to read everything to you, but you may want to look at page 782. Section 11.1, it really does have everything that's in this note guide. So you could read your textbook right now and get everything you need. So as you can see, we know parabolas are caused by quadratic equations. If they're vertical parabolas with a vertical axis, x squared is involved. And that's what our focus will be today. Little different than last year, though. We're going to look at an equation that is definitely different. I can tell you that because I teach Algebra 2 also. So x squared equals 4py will be the general form of an equation we're looking for vertical axis parabolas. Some reminders. There was a letter A because we used the 1A, 3A technique to graph. Well, we're going to still use that same technique. Remember, A is equal to 1 over 4p, or P is equal to 1 over 4A. We're going to need both of them depending on what we're finding. Remember, we're going to see a vertex. Today's lesson, 11.1, focuses only with the vertex being the origin, 0, 0. Nice and friendly. We're not going to translate and slide these anywhere except the vertex will be the origin. So we'll have to also find the focal point, which is called the focus, which has the order pair 0p. So p will be our distance from the vertex to that focal point. The directrix is a line y equals negative p. So it's going to be on the opposite side outside our parabola. And as you can see, it could be above or below depending on whether our parabola opens up or down. Let's move to what we're going to do, which is styles of problems. We're going to graph, obviously. You're going to do both by hand and calculator. Since you'll be testing from home, you better show what I need to see if you're going to be graphing it with a calculator and cheating a little bit. Graphing by hand will involve 5 to 7 points just like last year. A vertex, 2 or 3 points on the right side, 2 or 3 points on the left side. Equations of parabolas, that's our second style. We're going to create equations based on information I give you. It's kind of like a scavenger hunt, a puzzle all together. And finally, we may or may not get into some real-world setting problems like, remember last year, flashlights and satellite dishes. All right, moving to page 2. Here we go. First of all, just a quick recap. Graphing by hand, we use what's called the 1A, 3A, 5A rule, and A does come, in this case, not from what's in front of the squared term, but we're going to have to do a little work. A is found by using 1 over 4p. Again, I'm going to tell you, we're going to graph 5 points almost every single time. Again, remember I just said, vertex is always 0, 0. And we will need to do 3 things. I will want to see the vertex labeled. I will want to know the ordered pair for all points. And we'll need our focus and directrix in the picture. Let's make a 4th thing, our axis of symmetry. All right, we're going to stop here. We're at 4 minutes. So I'm going to come back, make a second video for graphing. Depending on the length, I might need a 3rd video for the equations. Have a good day. See you in a little bit.